4122. What determines the which form as a result of air structure or type of clouds being forced to ascend? A. The method by which the air is lifted. B. The stability of the air before lifting occurs. C. The amount of condensation nuclei present after lifting occurs. The correct answer is B. Cloud sort or structure is decided by whether the diskus is stable or unsteady inside the layer constrained upward. When steady diskus is constrained upward, the diskus tends to hold level stream, and any cloudiness is level and stratified. When unsteady diskus is constrained upward, the unsettling influence develops, and coming about cloudiness appears piled or cumulus advancement. 4124. Unsaturated air flowing upslope will cool at the rate of approximately dry adiabatic lapse rate. A. 3 degrees Celsius per 1,000 feet. B. 2 degrees Celsius per 1,000 feet. C. 2.5 degrees Celsius per 1,000 feet. The correct answer is A. Unsaturated air flowing up a slope will cool at a rate of approximately 3 degrees Celsius per 1,000 feet, which corresponds to the dry adiabatic lapse rate. The dry adiabatic lapse rate is the rate at which unsaturated air cools as it rises or expands due to adiabatic processes. It is a constant rate of cooling that occurs in the absence of condensation or the release of latent heat. The dry adiabatic lapse rate is approximately 3 degrees Celsius per 1,000 feet or 9.8 degrees Celsius per kilometer. As unsaturated air flows up a slope, it experiences a decrease in pressure and expands. This expansion leads to a decrease in temperature, and the rate of cooling follows the dry adiabatic lapse rate. This cooling process is often associated with orographic lifting, where air is forced to rise over elevated terrain. It's important to note that the dry adiabatic lapse rate applies only to unsaturated air. Once the air becomes saturated and condensation occurs, the rate of cooling changes to the moist adiabatic lapse rate, which is lower than the dry adiabatic lapse rate due to the release of latent heat during condensation. 4115. What type of clouds will be formed if very stable moist air is forced upslope? A. First stratified clouds and then vertical clouds. B. Vertical clouds with increasing height. C. Stratified clouds with little vertical development. The correct answer is C. If very stable moist air is forced up a slope, it is likely to form stratified clouds with little vertical development. Stable air inhibits vertical motion and tends to resist upward movement. When stable moist air is forced to rise up a slope, it will typically form stratified clouds, such as stratus or stratocumulus clouds. These clouds are generally flat and layered, with little vertical development or significant vertical growth. Stable conditions often occur when there is a temperature inversion, where temperature increases with height, or when cool air is trapped near the surface. In these situations, the air is more resistant to rising and mixing, resulting in the formation of clouds that spread out horizontally rather than building upward. 4118. What type clouds can be expected when an unstable air mass is forced to ascend a mountain slope? A. Layered clouds with little vertical development. B. Stratified clouds with considerable associated turbulence. C. Clouds with extensive vertical development. The correct answer is C. When an unstable air mass is forced to ascend a mountain slope, clouds with extensive vertical development can be expected. Unstable air is characterized by a lapse rate that is greater than the dry adiabatic lapse rate, which means that the temperature decreases more rapidly with increasing altitude. This creates an environment where air parcels are buoyant and have a tendency to rise. When such unstable air is forced to ascend a mountain slope, the upward motion is further enhanced. As the unstable air rises up the mountain slope, it cools adiabatically, and condensation may occur. This leads to the formation of clouds with extensive vertical development, such as cumulus clouds, cumulonimbus clouds, or towering cumulus clouds. These clouds have significant vertical growth, often reaching great heights, and can exhibit a cauliflower-like or anvil-shaped appearance. 4123. Which of the following combinations of weather-producing variables would likely result in cumuliform-type clouds? Good visibility, rain showers, and possible clear-type icing in clouds. A. Unstable, moist air, and no lifting mechanism. B. Stable, dry air, and orographic lifting. C. Unstable, moist air, and orographic lifting. The correct answer is C. Unstable, moist air, and orographic lifting would likely result in cumuliform-type clouds, good visibility, rain showers, and possible clear-type icing in clouds. Cumuliform clouds, such as cumulus clouds, are often associated with unstable air masses. Unstable air is characterized by a lapse rate greater than the dry adiabatic lapse rate, which means the temperature decreases more rapidly with height. This promotes vertical motion and convective activity, leading to the formation of cumuliform clouds. Moisture is another important factor in cloud formation. The presence of moist air provides the necessary water vapor for condensation and cloud development. When unstable, moist air is lifted, it becomes more buoyant and rises, resulting in the formation of cumuliform clouds. Orographic lifting occurs when air is forced to rise over elevated terrain, such as mountains. As the air is forced to ascend, it cools adiabatically, and clouds can form. Orographic lifting often enhances the vertical motion and can contribute to the development of cumuliform clouds. Good visibility is typically associated with cumuliform clouds, as they are often characterized by well-defined individual cloud elements with breaks or gaps between them. This allows for better visibility compared to more extensive cloud cover. Rain showers can occur with cumuliform clouds, particularly when there is sufficient moisture and instability present. The convective nature of cumuliform clouds can lead to the development of localized rain showers. Clear-type icing in clouds refers to the formation of ice on aircraft surfaces within clouds that do not contain supercooled water droplets. In the described scenario of unstable, moist air and orographic lifting, the presence of cumuliform clouds with upward vertical motion can create conditions favorable for clear-type icing within the clouds. In summary, the combination of unstable, moist air and orographic lifting is likely to result in cumuliform-type clouds, good visibility, rain showers, and the potential for clear-type icing in clouds.